Welcome to AlexGs Aquarium, everybody. Today I've got another update video on the 4,200 gallon display build. And today I am going to be talking about the finishing of the canopy interior, everything up here. This is one of the most important parts of this build because the canopy interior is part of the humidity control system. It supplies water back to the aquarium through its return line plumbing, which is in the top of the canopy. Also, I need to supply power to all the lights, pumps, other auxiliary equipment that I'm going to have on this aquarium to keep the fish and corals happy. And finally, I have to have lighting / equipment racks that are also going to be needed to hold up all the lights and power supplies and feeders, everything else you could think of. So a lot of really important stuff that's in the interior of this canopy. The first part of the aquarium canopy that I want to talk about today is the very top of the canopy up here. I have 18 sections between my T-beam cross braces of the canopy that were open. And getting these filled in with waterproof boards was incredibly important. This is part of the humidity control system for this aquarium. I need this canopy to be sealed up so that the moisture can be contained here and not get out into the rest of the house and be taken, so that the humidity can be ventilated out of this canopy and take it back to the fish room for mitigation. So really important that this is done. And for these sections of the canopy, I chose to use NRP board or non-fiberglass reinforced plastic sheeting to fill in these sections. Now it's very similar to FRP board, which is fiberglass reinforced plastic. Matter of fact, I used one FRP board for the very first section just to try it out, but then I needed to go to the store and buy more. I saw this NRP board was about 10 bucks a sheet less. It's still 100% waterproof board. Really the difference is though it's kind of an off-white color instead of a really bright white. It's a lot lighter in weight. It's not quite as strong as FRP board. I mean, it lacks the fiberglass, so it can crack a little easier. I did crack a couple of the 4x8 sheets while I was moving them. I kind of overbent them. Well, NRP board costs a lot less. It might not be as strong. It is lighter weight. And the best part is it's very easy to work with. Using a utility knife and a straight edge, I was able to cut all these panels out without having to get out any power tools or saws. So that was really nice. And to get this process going, I started out by just roughly cutting to the dimensions of each one of these sections. Once I had that done, I used a 1x4 and some 2x6 scrap to kind of wedge these panels up here. It was really nice so that I could take final measurements, cut around little parts of the canopy. Once I had done that, I pulled the boards down. Once I was happy with the fit, I sanded the inside of the T-beams here on the pond shield with some 60 grit sandpaper, and I also sanded the side of the NRP board that was going to be going up top, just lightly to rough it up. And then I pre-drilled a series of holes all the way around the perimeter just to make it easier to give final installation on the board. Then I cleaned it all off with isopropyl alcohol for both the NRP board and the pond shield here. And the reason I'm cleaning it is I laid down a bead of RTV around the entire perimeter so that I could seal these panels up there. Now we use the same technique as I did while I was fitting the panels to do final installation, where I used the 1x4 and the 2x6s to wedge these panels up here, and then I installed stainless steel screws around the entire perimeter. Once I completed that on most of these panel sections, I went through with the RTV and filled in any knots or seams on the canopy itself that just had little gaps. I'm trying to seal up everything as best I can so that moisture can't just start freely absorbing into the wood around it. Now, once I had that done, I just moved on to the next panel until I was done with all of them. Now, you probably noticed there is a section here missing. And there's actually 5 sections that I left out, and that's because my LED puck lights for the basement are in these areas, and they're actually my working lights inside the tank. So rather than covering that up and having to try and put other lights in the canopy, I just left these sections off for now. When I get to the point where I'm ready to fill the aquarium, I'll go ahead and install those as well. But for right now, they'll remain out. And then when I do install those panels, I'm actually going to remove these puck lights from the ceiling and just put cover plates on there, as there's no need to have these lights above the tank running. They're not going to do anything other than be little heat sinks and draw a little bit of power, since they're just LEDs. That's the very top of the canopy, very important part of the humidity control system. The next part of the aquarium canopy I'm going to be talking about is the return line plumbing. For this aquarium, I have two 2-inch return lines that have been plumbed in. They start on the far end of the tank is where they enter the canopy, and the water discharge for both of these return lines will be on this side of the tank here, where I'm in my non-reef safe fish section of the aquarium. Now, I originally roughed these two return lines in before I even started waterproofing, but as soon as I got that done, I went ahead and reinstalled them, and the plumbing was the first thing I wanted to get done with this canopy, because it is much more difficult to try and route plumbing around the light racks and electrical versus installing the plumbing first and then routing the electrical and light racks around it. It's much easier to do that. Now, with this plumbing too, I only have one return pump right now, but I installed two return lines, and there's a few reasons behind it. I think it's something important to consider anyone that's building a large aquarium like this. So, one return pump, it's an Abyss A400. It's got about 6,000 gallons per hour of flow through it at maximum. It's not going to actually reach that coming here because there's such a long plumbing run, but the overflows of this aquarium have a maximum capacity of about 14,000 gallons per hour, so a single return pump does not have the capacity to fulfill the maximum flow through here. That being said, there's some other factors that come into this too. Eventually, I will add a second return pump. I don't know if I'm going to max out my overflow, but it will give me capacity, but more importantly, having a second pump here will give me redundancy. So if I lose one of my return pumps for whatever reason, I will have a second one running that'll be able to supply water to the aquarium. And because the aquarium's in construction, installing this second return line now is a lot easier than trying to do this when the aquarium's running. Just everything I already have in here would have made it a more difficult job, but I can guarantee if the tank's full of water and fish and corals, I have all my cross braces in here and aquascaping, it would be an absolute nightmare to try and plumb another return line in the same fashion. So it was something I'd just rather spend a little more money up front and do the second return line, and then I could use it as needed once the aquarium goes online. Now, something else with this plumbing I think is important to share too is that these return lines are downsloped. Whenever I have done overhead plumbing runs for my previous 1,600 gallon system or in my fish room, one thing I always do is as soon as I can reach my maximum head height for the highest point the water has to be pumped, I start to downslope the plumbing from there. This does a couple of different things. The first, probably the most important, is it helps to relieve some of the head pressure off of that pump. Once the water gets beyond that high point and it is now going downward, it will have gravity on its side and it will just relieve a little bit of pressure off the pump. I don't know if it's going to make any big measurable difference. I'm sure there's some kind of engineering calculations I could do to figure it out, but I'm not going to do that. I know that it's going to help out at least a little bit and should just give me a little bit more efficiency here. I know that 30 feet of 2-inch plumbing has got a lot of water in it and it weighs a lot, so having it not push back on the pump's impeller and causing more head pressure is going to help. The other thing about having downslope plumbing is that if you turn your pumps off or you have a power outage, it will allow these lines to self-drain themselves. So that's the return line plumbing. It's going to remain roughed in until I am almost ready to fill this aquarium. There's just a handful of fittings that need to be glued, and I'm not sure exactly how I'm going to do my water discharges here. I'm probably going to go into the corners as the most likely place. The electrical system in the canopy is a very important part of this build, and to supply electricity into this canopy, the very first thing I wanted to do was make sure that I had some power redundancy and some distributed power. So I chose to install 3 15-amp circuits that are split across 10 outlet boxes in the canopy. Now, the circuits aren't energized or anything yet, but when they are, they're going to receive AFCI, GFCI breakers. AFCI, or arc fault circuit interrupters, are meant to help prevent fires where you have an arc that occurs between a hot wire and a neutral wire. And then GFCI, which is much more common in the aquarium world, is ground fault circuit interrupter. It looks for current being detected on the ground as a ground fault, and again, that will turn the power off. Now, having 3 15-amp circuits in this canopy will help to split that load of power up. And also, if there is something that causes a breaker to trip due to an arc fault or a ground fault, the hope is that it will only trip that particular breaker and won't trip all of them. So I only stand to lose about 1/3 of what is in the aquarium. And that power diversity is very important to kind of split things apart. So I have split up the circuits through these 10 electrical outlet boxes. Now, starting over by the window, circuit 1 in those 2 boxes. Then we're circuit 2, circuit 3, back to circuit 1. Then we have circuit 2 and these 2 outlet boxes, and then circuit 3 there, there, and there. And all the boxes were installed in PVC and weatherproof boxes, and they were all mounted nice and high to get them the maximum distance that they can be away from the water. I only have 1 box that's mounted inside the tank, and even that one is mounted a little higher. And I wanted to make sure that I had outlets along the entire perimeter of the tank that were easy to access. The nice thing is I can literally stand right here, have access to my power. That really blends nicely with the light rack design that I did, because I wanted to make sure every light rack had power. I also wanted to make sure that any other part of the aquarium around the perimeter where I might have to plug in pumps or temporary equipment or whatever it may be, I have convenient plugs all the way around. So that is the goal of what I was trying to do here, is make a simple power scheme that's fully protected and accessible while also being able to be in the environment that it's housed. Now to the final piece of the canopy interior, and arguably one of the most important, the light racks. Light racks for this aquarium are going to support the lights, potentially power strips, water pumps, automatic feeders, might have other probes or other measuring devices, cameras. I mean, you name it. I need something to hold equipment above the water. These racks need to do it. And I spent a lot of time designing these light racks to kind of meet all my criteria and be easy to work with. Probably the biggest problem that I had to overcome with these light racks was, how am I going to access the equipment at the back of the tank? Unlike previous tanks that I've had in my fish room or my old house, where I've been able to access from both sides, you know, I can get to half the light rack on one side, half on the other. It's not a problem. With this tank though, even reaching the middle, it's going to be difficult. With the tank 6 feet front to back, it's a big challenge. On top of that, I have 18 feet of this aquarium that I cannot get to the back of the tank unless I go for a swim, and I don't want to do that while I'm messing around with power on a light rack. The first design challenge for me was, how do I make the equipment come to me? There's really only one solution for that, is I needed to have a light rack that could slide. And that is why I made these on a track that allows me to pull the light rack out almost completely. I could reach all of the light rack here. If I get on a little step stool or something, I can reach the very back of it here. But the whole idea is to make this easy and convenient to do work on, and that is where I came up with this design. So this light rack is made out of 20 millimeter 80/20 aluminum. This stuff is great because there's all kinds of connectors out there that make it real easy to configure this exactly how I wanted it. And I started by just making a real simple square frame for these light racks, and then as I get lights or equipment, I can start to modify them according to what I'm actually going to be putting on them. I went through a number of iterations of design and trying to figure out how to get this to slide out. I finally landed on this design here. Now, you'll notice the light rack does sag a little bit when it's extended fully, and it's just a design choice here with this. I will make up a stanchion pole using a 2x4 or something to be able to support this light rack up fully when it's extended and I need to do maintenance on it. For some of these light racks though, the load on them is going to vary quite a bit. For example, I'm standing at the non-reef safe section of the tank right now. This third of the tank is going to get some very basic lighting. It's not going to get anything really high end or need a huge amount of concentration for it. And therefore, it's not going to have to hold up a bunch of weight. Some of my other racks, however, are. And really, the way I designed these racks was to make them expandable, but also be able to hold up a decent load. I figured the heaviest light rack could be somewhere between 50 and 100 pounds, and these light racks should have no problem holding that up. Now, there's two parts to the light rack. First, there is a cradle that is hanging down from the canopy, and that is the anchor point to the canopy. And through the anchor point here, I've got these vertical struts. These have been bolted through with stainless steel hardware, top and bottom. Because they're holding the load, I don't want any chance of just a screw-on 80/20 connection slipping or getting loose. And therefore, I decided to just drill through and put stainless steel hardware on. So this whole cradle has been bolted through. Now the light rack itself sits on top of this cradle, and I used PVC as a glide on the track, and it just helps hold this centered and also minimizes the amount of aluminum rubbing on aluminum. It probably wouldn't make a difference. These light racks aren't going to be moved too often. I wanted to have a nice little glide surface. Now, when the light rack's fully extended, I use stainless steel U-bolts through the light racks to hold them onto the cradle so they have a physical attachment point and can't just fall off or, fall all the way forward. There's something holding it up here. So that's the purpose they serve. And the PVC for these light racks I purchased was just 1/4 inch PVC from Home Depot. I used PVC glue to just glue them into a little H-beam or I-beam, depending on which way you go with it. And then the aluminum just sits inside there as a little track. Allows it to glide through there. You might be asking, why did I make this? Why not get 80/20 glides? They do sell those. Or why not just go with a really large industrial drawer slide? And I will say, I did consider both of those options. However, there were some disadvantages to going that route. So the 80/20 glides work really well if you have a track that's the whole extended length. And because I need to go beyond where there will be a track, the glides just weren't that great of an option, and it wouldn't have been any different than how this is, where it would have had to go past it, and they're very expensive. So that kind of ruled that out. Now, probably the better option would have been to go with industrial stainless steel drawer slides that extend out 30 or 40 or more inches. And you can get them. generally they're rated for like 400 or 500 pounds because they're being used in big gang boxes or tool boxes at an industrial level. And there were a couple of problems with those. One, those drawer slides alone would have cost as much as all the materials for all the light racks I built. They were that expensive. It would have doubled my cost. And that right there was something I really was not that keen on. The other piece as well was in drawer slides like that, they all have ball bearings and grease on them. And I've been working around aquariums for a really long time, and when you take salt spray and dust and salt creep and metals, things can corrode, and it might not be very easy and it might not ever happen, but ball bearings are going to be the more susceptible part of that. The other thing that really concerned me too is that there's going to be a grease or lubricant on those drawer slides, and it's just me. I get really paranoid about stuff like that. Even more so now after some of my experiments have not gone quite to plan with trying out new things. And I don't know if those lubricants would be toxic if they ever got in the tank. So better to just avoid them. I've had plenty of aluminum over tanks, stainless steel. I'm not concerned about the PVC. This stuff's, most of my skimmer parts for it have all been made out of it, a lot of pieces. So these are all materials that I've worked with and trust. That's where I came up with this design. And as I said, I've got a lot of extra pieces here. And this stuff was nice. This 20 millimeter stuff is meant more for 3D printers, CNC machines. It really does a great job though. And I got it pretty cheap on Amazon. It was like a box of 10 60-inch pieces was only like 130 bucks. And compared to buying like 7 or 8 foot full 80/20 at 1 inch, it's, a couple pieces of that cost more than $130. And I'm really happy with the design. I'm really looking forward to the day that I can start getting some lights on here. I think it's going to look really nice when it's done, and also give me a nice light height where everything's got some good working area underneath it. So that's all of the interior of the canopy and its finishing. With this being completed, I am now ready to go on to putting the exterior finishing onto this aquarium and giving it a nice furniture grade look. There's nothing else left that I have to do before I have to get this aquarium up and running. That's it. There's nothing else. Oh yeah, that glass stuff. I do need that. If you've been following me on Instagram, or if you're on the Reef Beef podcast Discord channel, you've probably seen this contraption behind me. And this contraption behind me here is my glass sled and ramp, which is going to be helping me get glass through the basement window there and bringing it into this aquarium. I have 4 sheets of glass that are at or near 12 feet long, so I needed to devise a way to bring those sheets of glass into the basement, and wouldn't you know it, they fit right on through that window. So I built the ramp and sled. I've already tested it. I'm confident that it'll work and help bring the sheets of glass into the aquarium. But that begs the question, why have I built this contraption? Well, that is because I have ordered the glass for the aquarium, and I'm really excited to say a couple days ago I got the phone call. The glass manufacturing is completed, it's ready to ship, and it's going to be heading this way soon. So as of the filming of this video, the glass hopefully will be on its way in the next week or two. I'll get it into the tank. Lots of exciting news for the aquarium system and the build. A lot of stuff's going to be happening over the next few months. I look forward to sharing it. If you liked the video today, go ahead, give it a thumbs up. If you want to see more, hit subscribe. I only release videos now when I have major updates on the tank, but with all this stuff happening soon, there's probably going to be a few more videos. If you got questions, go ahead, leave them down in the comment section below. I'm fairly active on Instagram. I've also been pretty active on the Reef Beef Podcast Discord channel. It's a really good group of folks there, and been having some really great in-depth reefing conversations. Really good for kind of challenging ideas and really thinking a little bit more in depth about the hobby. So I've been really enjoying the community there. That's the video. As always, thanks again for watching, everybody, and I'll see you on the next video.